New Year, everybody! Welcome to Dashing Edu. Today's lecture on maths, essential for the students of O and A level, BCS, SSC and HC English version and job students. Today's lecture is on interconversions of quadrilaterals and their area. You know quadrilateral, four-sided area, 1, 2, 3, 4. So particularly number 1, this area, this is A and this is and this and this. So this parallel to this and this parallel to this parallel to and this. So opposite sides are equal. A and same, B and B same. So in this parallelogram, the distance between this and this in each point same. The distance between this and this in each point same. So conditions of the parallelogram are A and A same, this and this is same, and also parallel. This and this parallel, this and this parallel also equal. Opposite sides are equal. But diagonal, this diagonal divides this whole area into two equal regions. I mean this triangle and this triangle are equal. Similarly, this diagonal also divides this whole region into two equal regions. This angle and these opposite angles are equal. These angles and these angles, opposite angles are equal, but not 90 degree. So in this case, if we draw these diagonals, this angle, this angle, this angle and this angle same, this angle and this angle same, also this portion and this portion equal, this portion and this portion equal. I mean this portion and this portion equal. Now we have seen this and this distance here and this distance same. So if we draw the perpendicular line here, I mean this 90 degree, then we see the height. So the area of a parallelogram is equal to this side into this height. So area of a parallelogram equal to AH, this side to height. Thank you very much. Now area of a parallelogram can be found in another way if the diagonal is given and the height from this angular point to this perpendicularly drawn, I mean from this point to this point, height from this point to distance between this point and this diagonal, say it is height. This is D, diagonal D. So the area of a parallelogram can be DH, I mean this is diagonal and height is angular point and perpendicular line on this diagonal. So in two ways we can get the area of a parallelogram. This AH means the opposite sides, this one, and the height between the opposite side. Another way is diagonal into the height between the distance between this and this. Now we can see this thing, this area, this region. Let's forget this side. Let's forget this triangle. So what is going to happen? Number 2. So it has become 90 degree perpendicular to this side. I mean this parallelogram and this rectangular almost same, only difference is 90 degree angle, but here no 90 degree angle. So here no 90 degree, this is called rectangle. So rectangular. So in this rectangle, this all the conditions are almost same, but here only 90 degree, angles are 90 degree. So area of a rectangular equal to AH, more simpler than the parallelogram. Number 3. Now if we cut this equally, this side, and this and this region, this equal, this equal, so cut this here, we can separate this. Now this side are all equal and 90 degree, all the angles are 90 degree. You know, this is square. So very simple, the area of a square equal to A into A, I mean A into height, that means this is A. So this area of a square equal to A into A, I mean A square. Very simple. Now another interesting thing is a kite, you know. The condition of a kite is that this side and this side is equal, this side and this side is also equal. Okay, so if you draw diagonals this and this diagonal D1, this one D1, this one D2. So what happens? These diagonals intersect perpendicularly. So the conditions are this equal to this equal to this, and this is 90 degree because perpendicularly intersect. Okay, So this area is equal to this area equal to this area, this whole area and this whole area is equal, but this area and this area is not equal, as well as this angle and this angle is not equal, but this angle and this angle is equal. Okay, so the area of a kite is equal to half d1 diagonal and d2, that is half the product of the diagonals. Similarly, number 5, rhombus. In rhombus, the conditions are almost like the square. Here the angle is 90 degree, all the angles are 90 degree, but here no angle is 90 degree. So the difference between these two things is that, the difference between the square and the rhombus is that in the rhombus no angle is 90 degree. If any angle is got 90 degree, then it will be converted into square. So if these two diagonals are drawn, then this will be 90 degree, this will be 90 degree, this will be 90 degree, this will be 90 degree. That means all the angles, the diagonals bisect each other perpendicularly. Okay, this side, all the sides are equal. So the area of a rhombus is half d1 into d2. Now number 6, trapezium. Trapezium, the conditions, this side and this side are parallel, this and this opposite sides are not parallel, and so the distance between these parallel sides h, and this a and this b. Two parallel sides are a and b. The distance between them is h. So the area of a trapezium is half h, a plus b. Half the distance of these two parallel sides and their sum, a plus b. So that is all about the area of quadrilateral and their conversions. Those who have already subscribed my channel, thanks them very much, and those who are still not subscribe my channel, please subscribe, share, like and comment. Thank you very much. Thank you very much.